In the last video, we talked about GQ proteins. This video, we're going to talk about GS, G stimulatory, and G inhibitory, GI proteins. So just as a reminder, there's like 1,000 different G proteins in our body. 50% of drugs are targeted towards G proteins. So these are important cell signaling pathways that we need to know about. And it's important to go through these pathways and understand them to understand pharmacology and physiology. So back to the cell, we have, just like with the GQ, we have a serpentine receptor. So it passes through the lipid bilayer 7 times, 1, 2, 3, 4, 5, 6, 7. Here's our C terminus, here's our N terminus. So that's a protein. And we have, it's a G protein coupled receptor. Here's the G protein, it's coupled to the receptor. And we have 3 different subunits. So this is a heterotrimeric G protein. 3 different protein subunits form this complex. So we have alpha, and in this case, it's not going to be Q, it's going to be either S or I, depending on what we're going to start with S. So let's say it's GS. And then we have beta gamma. And again, there's lipid moieties that's holding these subunits to the phospholipid bilayer because these are polar proteins. And there's a lot of different ligands that combine to GS and GI G proteins. Just to name a few, here's some endocrine hormones: follicle stimulating hormone, luteinizing hormone, adrenocorticotropic hormone, thyroid stimulating hormone, corticotropin releasing hormone, human chorionic gonadotropin, antidiuretic hormone is both GQ and GI, melanocyte stimulating hormone, parathyroid hormone, calcitonin, growth hormone releasing hormone from the hypothalamus, glucagon, and H2 or histamine type 2 receptors. All of these are different endocrine hormones, but remember, most of all the sympathetic and parasympathetic receptors are on their effector organs are G proteins, and most of them work through the GS and GI pathways. We talked about the GQ works on alpha 1 and muscarinic type 3, but all the other ones are involved in GS and GI. And so the other 4 adrenergic receptors and the other 4 muscarinic receptors are either G stimulatory or G inhibitory. So let's see what a G stimulatory would do. So let's say we have norepinephrine that binds to, one of the beta, like a beta 1 receptor. So what it will do is it will cause a conformational change that will cause this alpha subunit to drop GDP and pick up GTP, turning it on. So once it gets turned on, it'll slide down the lipid bilayer, just like in the other video, except it'll go to a different enzyme that's embedded in the phospholipid bilayer called adenylate cyclase. And it's an enzyme that takes ATP that's in the cytosol, chops off 2 phosphates, so it creates a pyrophosphate and CAMP, or cyclic AMP, or cyclic, adenine monophosphate. So you're cutting off 2 phosphates, forming a cyclic structure. This is the second messenger. It's going to go and activate a protein kinase called protein kinase A. Remember, kinases phosphorylate things. It could either turn things on or turn things off. So different things that can happen when you phosphorylate things. You can change the membrane permeability. We have proteins in our membrane. It can open up to different ions and change the permeability of the cell. You could change the metabolism in the cell by either activating or deactivating an enzyme. Or you could even phosphorylate a protein called a transcription factor. Once it's phosphorylated, it may translocate into the nucleus of the cell, bind to the promoter site, and affect gene expression. So this is G stimulatory. What about G inhibitory? G inhibitory, or alpha protein, determines what the G protein is. So now it's inhibitory. Let's say we have a ligand, and maybe this time again, it's norepinephrine, because you could have a G inhibitory. And so when it binds to the ligand, it causes a conformational change, again, dropping GDP for GTP. It slides down, and this time it'll activate adenylate cyclase, and adenylate cyclase will no longer be making CAMP. If you block the conversion of ATP to CAMP, you're decreasing the activation of protein kinase A and decreasing phosphorylation of the different things that can happen inside the cell. So that wraps up 3 different G proteins. We have the GQ in the other video, GS, and GI.